Hello everyone, hello, this is Aurora, and we are getting ready to just start here in just a minute. This is Aurora with the Central Coast Astronomical Society. Welcome everyone to our special stargazing / astronomy session for tonight. I am really excited. We have a special presentation that we are going to be sharing with you just for tonight. And so I know we're a minute or two early, so I just wanted to give a shout out to everyone. If you can go ahead and type in your name as well as where you are connecting from in the world, that will help us out astronomically speaking about what we answer and what we talk about for tonight. We've got some things we're going to be doing a little bit differently than our regular stargazing session. So I just wanted to kind of find out where everyone is so we can make sure to hit something from your end of the your little corner of the world. So welcome everyone, welcome. My name is Aurora with the Central Coast Astronomical Society, and tonight we are going to be doing a very special session. So I actually have Brian with us. He's going to join us in just a minute. He's actually also typing furiously, answering all your questions in the chat box as well. And so he and I are going to be presenting tonight. Now, last week, Kent and I were presenting. We actually recorded it in advance because we weren't sure exactly how long we were going to go, to be honest. I don't know if you downloaded the astronomy guide for last week's session. It's 28 pages, and we only got through half of it. So we were together, I think, for about an hour, maybe a little bit more for last week. So if you would like the stargazing session that Kent and I did, it's Halloween based. We didn't get through the whole thing. We did the most important ones, the ones that we particularly like the best. And so you can still download this on the website. I'll show you where that is kind of near the end of tonight's session. And so for tonight, we're going to actually focus on some things that are going to be super easy, no matter if you live in a big, bright city, even if you live in like San Francisco or LA, you'll still be able to look up and see these objects because they are so bright. And so we're going to hit some really, really good targets for you tonight. And if you have any questions as we go along, there are a couple of different ways we can get those answered for you. The best way is to put them in the chat box. Do you see the chat box right below? It's like exploding all over the place. People are dropping in their names. That's awesome. So go ahead and type in your questions anytime during tonight's presentation. And our astronomers from CCAS, Central Coast Astronomical Society, are also on with me, and they are helping support kind of behind the scenes by answering your questions. So if you get an answer back, chances are it's from a real astronomer, which is super cool, but real amateur astronomer. Okay, the other two ways are you can text, please don't call, but you can text in your questions to the phone number at the bottom, and I'll read it out loud in case it's a little too small. I'll read it twice. You ready? It's 805-242-6415. So it's 805-242-6415. And so you can text that. Again, nobody's there, you can't call it, but you can text your questions and we'll get those as well. Or you can simply send an email. So if there is no chat box on how you're connecting to our session tonight, you can just send me an email. It's questions@centralcoastastronomy.org. And so this is a free session tonight. This is something that we love doing. We love sharing the night sky with the public and just getting people excited about astronomy. One of the really cool things that's been happening since March is people are discovering astronomy, and we couldn't be happier. So CCAS has been in operation since 1979. It was actually a group of professors that were young chemistry and I think another department as well. Lee, you're going to have to help me with this. So who actually started it because they just wanted to learn how to stargaze. And so now, over 40 years later, we're still going strong. We actually I think, Brian, we have over like 1,000 people now on YouTube. Yes. And we just started our YouTube channel, what, like a month or two ago? So it's really exciting. So all right, so if we're going to get started, I'm going to bring Brian on in just a second. I have one more quick thing. We are going to be answering equipment questions near the end. So if you have telescope, astronomy, eyepiece, telescope, eyepiece, binocular questions, save those for the end. We are going to get to those. And I promise we'll answer as many of them as we can, as well as, what do I use for beginner telescope? Or I want to do this kind of deep sky stargazing. What do I use? So we're going to answer those, but we're going to do that near the end. Right now, though, if you don't already know about skymaps.com, S-K-Y-M-A-P-S, skymaps.com, write that down. Grab a pencil. You're going to need it for tonight. Grab a pencil and a piece of paper. Skymaps.com is a place where you can download what's up in the sky tonight. And they do it for the northern and the southern hemisphere. Real quick, in case you've ever seen these and you're like, I don't know how to use this thing, that is so confusing. We're actually going to be covering some of the objects that are on here. So if you have a highlighter or if you have a pencil, that would be great. You can kind of make notes as we go along. Yeah, if you don't have this, don't worry. You can just sit back and relax and enjoy this show, and just know that you can print this out after. How you use this real quick is there are designations up here for north, south, east, and west. It goes over your head. So over your head, and this is what you're going to see in the night sky. So when you take it off, you're like, oh, Great Square Pegasus. So you line up the north and the south and so forth. Make sure this is oriented correctly. So this pole here is actually pointed towards the south direction. And then when it's over your head, now when you take it off, you're like, oh, Great Square Pegasus. Oh, there it is. And it'll just pop right up at you. Now, it does take a little bit of skill to get to know how to use this thing, but between this as well as an app on your phone, you can use Stellarium, you can use Sky Safari. There's a million of them. Try as many as you like out there. There's a lot of different ones. You can just try and see how you like them. Between those two, you'll be able to use the information that we're going to give you tonight. You'll be able to go outside and be able to find things. And so that's our goal for you tonight. So not just to go, ooh, ah, this is amazing, and it's going to be amazing, but that you'll be able to take this and be able to share it with others and show them how you can start to notice the certain patterns in the sky so you can start finding this stuff yourself and really understand what it is you're looking at instead of all these little shiny dots up there. Okay, Brian, are you ready?
I'm ready.
All right, Brian, I just realized I don't have a way to share you with everybody, so give me just a second. Let me grab you, and I will put your picture up. And do we have any quick questions you want to answer really quick about maybe where? I see one about where's the website.
Yeah, the website is centralcoastastronomy.org, and you can also find us on Facebook too. And we did have one question come up on the chat asking if there's any good comets right now. And yes, we wish there were, but while there are some comets, you need a pretty good telescope to see the ones that are out. So we always have our fingers crossed that a new will be discovered and become bright enough, like what we had with Neowise earlier this year.
Yes, definitely. Let me go ahead and share my screen without me on it. So hang on just a second. There we go. I got it. Okay. All right. We are ready. So Brian, you want to introduce yourself real quick?
Hi, I am Brian Cox. I am also with Central Coast Astronomy, and I'm also part of the outreach team down here at Riverside Astronomical in Southern California. And really glad to be with you all today. And thanks, Aurora, for having me on to join. I am usually the unseen keyboardist at the chat window, but now I get to be on camera too.
Yes, you do. We're very, very excited that you're here. All right, so Brian actually has put together some objects we're going to take a look at. And as Brian is talking, I'm going to actually share my desktop with you. I have a planetarium software that I'm going to be sharing. It's called Stellarium, like stellar IUM, Stellarium, and you can download it for free from the internet, stellarium.org. Is that right, Brian?
Yes, that is right.
Okay.
Exactly, and I put it in the chat also.
You did. Okay, great. Thanks. So as he talks, I'm going to be zooming around so you can see exactly what we're looking at and also how to find it. Now, if you've just joined us, I know people hop on and off all the time. This is Aurora with the Central Coast Astronomical Society. We are sharing stargazing with you tonight. We've got several different objects. We're going to show you how you can find them, no matter if you live in a dark country town, lucky you, or under the bright lights of a big city. You'll be able to see these objects. And then we're also going to share some astrophotography images from our members, as well as answer your equipment questions. And we have a bunch of resources we're going to tell you about as we go through tonight. So we've got a lot planned. I wonder if we're going to get through it all, Brian. What do you think?
Yeah, I don't know. We'll see how it goes. Really keep those questions coming online, and then that might fill a lot of our time. But we love answering questions, so let us have it at any time.
All right, Brian. So what do you want to look at first? If you were a newbie and you really wanted to go in the night sky, and you're like, wanted to impress your girlfriend or your wife, and or your set of friends, what would you go look at?
You know, with right now, autumn is so great for viewing planets. And that seems to be what people notice when they glance up at the sky. So I think we should talk about planets right first.
Okay, let's do it.
And let's do the first two. Let's talk about Jupiter and Saturn
Okay.
because they're actually northeast of Sagittarius. And wondering how many of you joining us and watching can recognize that name Sagittarius. What do you think of Aurora when you hear Sagittarius?
I think of a guy with a bow, and I also think of
Oh,
a
you do.
teapot.
I think it's time for tea
You
when I hear it
do.
because I think teapot.
Okay.
Yeah.
So
Yeah.
Sagittarius,
So
should we show people where it is?
I think so. Let's do that. And I can kind of describe, when you look for that teapot for Sagittarius, by the way, Jupiter and Saturn are visible right after the sun sets. So no waiting till 4 or 5 in the morning for these gems. And all you have to do is you could start at the teapot and really about the orientation that the constellation Sagittarius will be. You just look slightly up and to the left, and those two bright objects right there are Saturn and Jupiter.
Okay, so a teapot. So I've got things labeled here. For those of you who this is new to, oh, let me actually remove the. Okay, you guys got the phone number and the email. Can I make that go away? So 805-242-6415. Make sure you've got that. Okay, it's going to go away now. So you can email your questions to questions@centralcoastastronomy.org. Okay, so here we go. Well, my night sky doesn't look like this. So you can see things are labeled. We have pictures. I mean, wouldn't that be cool if we could do that?
Yes, it would.
That's not the way the sky looks. The sky is going to look like this, and there are no labels whatsoever, and it looks like a whole bunch of dots. Some dots are different colors, some of them are different sizes, some are different brightness. How do you find anything? Okay, first we're going to put the landscape back in. Okay, so we are in the northern hemisphere right now. It's okay if you're somewhere else, and I will actually remove the horizon for us. And if you notice, I've got some markers here. Here's west, southwest, and south. So what we're going to be doing is we're going to go out and we're going to look southwest. And right above the horizon, we're going to see a bunch of bright stars in here. And so what that's going to tell us is we're going to be able to look up, and the brightest stars are going to be Jupiter and Saturn. So Brian was talking about Sagittarius. Let me remove my markers here. Okay, so how do we find Sagittarius? So what you're going to look for is you're going to look for a teapot that's on its side. Do you see the kind of all these really bright stars in here? So one of the groupings is going to be a triangle, and one of them is going to be kind of like a trapezoid. And we're going to have a little hook for the arm, and then we're going to have a little teapot handle. And so if we connect those in our mind, we can see this looks like a teapot as it's pouring out tea. And you can see that here. And so this is what he's talking about. Look for Sagittarius. So if you've never seen Sagittarius before, this is, well, it's a bigger constellation, isn't it, Brian? It's actually...
It is.
Yeah, it
Yes,
extends
I know.
all.
I always think of the teapot, but it actually stretches out quite a ways.
It does. It does. So the easiest way to do this is just go outside tonight and look between south and west and just look straight up above the horizon, and you will see two really bright stars. One is going to be Jupiter, and one is going to be Saturn. And then if you want to really get fancy and you want to look for Sagittarius, just look right below it and see if you can see the curved handle and the spout, and chances are you will have found Sagittarius. All right, Brian, what's so cool about
Excellent.
these?
Jupiter, let's talk about Jupiter first.
Okay.
And boy, because you can't miss it. And it's actually called a gas giant, and it is the largest planet in our solar system. And I really like how you can zoom in like that. This planet, Jupiter, is actually more than twice the size of all the other planets in our solar system combined. And in fact, if you're looking at Jupiter, you could put 8 Earths across the equator, and I'm sorry, I'm going to say that again, 11 Earths actually would stretch across at the equator in Jupiter. That's how big of a planet this is. Now, just like you zoomed in, a view through binoculars would show us those 4 Galilean moons. And I think we can actually see those in the view that you have.
Yes.
Those are called Io, Europa, Ganymede, and Callisto. And in binoculars too, depending on the size of your binoculars and how good the seeing is, you may actually see some slight striping across the disk of the planet.
Yeah, It looks
And
like this maybe in my 8-inch, my really good 8-inch, it'll look like this.
yes, exactly. Now, how about a view with telescopes? Boy, the more power that you can throw at Jupiter, the better. The more you can magnify, the more you're going to see those bands going across the face of the planet. And these stripes and swirls are actually clouds of ammonia and water that are floating on the main atmosphere of Jupiter, which is mostly hydrogen and helium. And believe it or not, those bands go all the way around the planet. And of course, you may also recognize one really big red spot depending on where Jupiter is in its rotation. And that big red spot is an amazing storm. And I remember seeing pictures of that way back with the first images I saw in the late 70s of Jupiter. So it's been around for quite a while.
It has, and I actually have a. Oh, I'm gonna wait till you share more. Go ahead.
Oh no, that's okay.
I was gonna let
sure.
the cat out of the bag early. No, you keep going.
So a few other interesting things about Jupiter. You may wonder, well, where's the name come from? Jupiter is named after the king of the Roman gods. And not surprisingly, when it's really the king of the planets in our solar system. Now, we're going to talk about the moons for all of the planets, whether they have them or not. But it's almost like Jupiter and Saturn are in a contest for who can have the most moons. And now, while of course I don't think the planets care, astronomers are always racing to find them. So when I checked earlier today, the current moon count for Jupiter was at 79.
Whoa.
While of course Earth has one, but Jupiter 79 moons. There's an interesting, by the way, mystery or dynamic on how long it takes Jupiter to get around the sun versus how long the length of a day is. But let's take a moment to enjoy those. There's Jupiter's moons. I like that picture.
And this is actually an image from, I think it's a 5 or 6-inch telescope.
Okay, yeah, so that helps give people an idea of what they could see.
Mm-hmm.
If you think about the size of telescopes you have at home or binoculars. Mm-hmm. Of course, you'd need a really nice telescope to see pictures of the moon, like moons like that. That's probably from Voyager.
Oh, like this? Yes. No, you would not see this with a pair of binoculars.
No.
Okay, now what were you saying about the moons?
Well, I was just thinking, wow, we have this picture showing that neat image of Jupiter with the 4 moons stretched out. Imagine this is similar to what Galileo saw when he first pointed a telescope up at Jupiter and all of a sudden saw those 4 dots that changed day by day. And that was part of what helped scientists to understand that there were objects orbiting around other objects. And Jupiter is a great object to look at, even different times of the same night, and definitely over multiple nights, and you'll see how those moons move around as they're orbiting around the planet.
Mm-hmm. And how do you tell which one's which?
There's neat little apps and programs and websites that will help you do that, tell which moon is which. But even in Sky and Telescope, they have a chart that will show you for each, since Sky and Telescope comes out each month, they'll give you a little table and you just look at the day. There it is. And of course, Neowise is appropriately on the cover of that month.
Oh, it is. This is for November, isn't it? It is. Okay, wait. I'm going to see if I can find it before you're done describing it.
No problem. Yeah. And so all you do is you just take a look at what day it is, and then it'll show you a little chart. See the squiggles swirling back and forth. That shows you the orbits for those moons, and then you can tell what they are. Keep in mind, sometimes you may not see all 4 moons, and that's because one moon could be behind Jupiter or in front. Some of the best pictures I've seen of Jupiter is when they catch the shadow of one of those moons cast right on the face.
Yes, those are really cool.
Yeah. So, Aurora, we had an interesting question that came up on the chat. Zeke asked, if Jupiter had water like Earth, how would 79 moons affect the planet?
Surfers would love it.
Yeah, that'd be quite the dynamic. It's with the fact that, oh, there's a great picture of moon casting a shadow on Jupiter.
This one was taken by
The
NASA.
thing, yeah. So, the thing about Jupiter is it is so massive. I'm thinking that its moons do not have that strong of a tidal effect on the planet.
And the moons are actually undergoing a lot of tidal forces because they rotate so much faster than they should. I mean, they do,
Yes.
but they have so many tidal forces going on inside. The moons are different than our moons in terms of how big they are compared to the planet, as well as how fast they've been zooming around the planet. So that's a really good question. It's hard to answer because Jupiter is a gaseous giant and not a terrestrial planet. So I'm still looking for how to get my face back on. Here we go. This
Okay.
is the most complicated setup we've had so far.
Yes.
So the Earth has water tides and it also has land tides. So even though you don't notice it throughout the day, there is the ground will actually rise up over the course of, correct me. I can't remember how long exactly the time length is, but it goes up 18 inches and then it settles back 18 inches for
Yes,
one
amazing.
complete
So
cycle.
we're experiencing it very slowly, so we
Very
don't feel
slowly.
it like a roller coaster, right?
Right, exactly. So, because Jupiter is a gaseous planet, you'll have those same effects happening on the gas, but because gas is so much different than a solid or a liquid, those
Right.
effects are very different. So, all right.
All right, excellent. Well, that's a good question.
Yeah.
Let's revisit. Uh, we were talking about the length of a day on Jupiter.
Mm-hmm.
So for us on Earth, a day is 24 hours. So we sit on one spot, rotate around, 24 hours to get around.
Mm-hmm.
On Jupiter, slightly faster at but one day is 9 hours 56 minutes.
Oh
So
my.
the surface Jupiter is really whipping around there.
Yeah.
And I have one last fact I like to share. When we're talking about the distance from the sun to the different planets,
Mm-hmm.
one of the standards that we use is called an astronomical unit, and what that is the distance from the Earth to the sun as
Mm-hmm.
an average distance, which is 93 million miles. So if you see someone talking about AUs, one AU is about 93 million miles.
Mm-hmm.
We're going to use that to gauge our distance to the other planets that we're talking about. So Jupiter then is 5.2 astronomical units away. So quite farther than we are.
A lot farther than we are.
Yes.
Definitely. And awesome. Now, there's been a number of questions about Jupiter, including the volcanoes. Let's see. So yes, the volcanoes on the moons. I saw a couple of questions fly by. I don't know if that was email or chat. I'm sorry. But one of the things that happens because, for example, on Io, the volcanic activity is driven by the tidal forces. The Io being squished and squeezed, just because it's so close and it's zooming around so fast, and so that the volcanic activity is driven by the tidal forces, just being squished and squeezed. And actually, I think it's being shocked as well every time it goes around the planet. There's certain places due to the magnetic forces of Jupiter, and that it will actually shock Io as it goes by certain areas with, I think it's like 3 million amps or something like that. So it is not happy. It is not a happy planet.
And so I sent you a quick message on Skype. Stephen asked a great question that I'd like to answer. He asked, how close could an astronaut get to Jupiter? And the answer is very close. The astronaut, he or she could get so close that they crash in and are crushed by the atmosphere. The problem with Jupiter is getting back out. So, so we have to be really careful when we go to that planet because its gravitational pull is quite significant.
Yes, good luck
And
getting back home.
exactly.
I
You know,
understand.
I
My microphone, is that the
Yeah,
problem?
they're
Okay.
asking for it to be a little bit louder
Let me
as it
see if
comes
I
over on
can
YouTube.
adjust that. Okay. All right, give it a minute to cycle through.
Okay, great. Awesome. Well, so boy, we spent some good time here on the king of the planets. I'm thinking we might go over to what appears to be neighbor in the sky, Saturn. What do you think?
Yeah, let's do it. So how do
All
we
right.
find Saturn? So I look up.
Well, yeah,
I,
right now, look for that teapot, Sagittarius,
Mhm.
and then the first of those two disks that you get to or objects will be Jupiter right now. And then just to the left and a little bit higher in the sky will be Saturn. By the way, you may also notice that Saturn will look a little more yellow orangish depending on your seeing conditions. I want to point out too, remember all these planets are orbiting around the sun, so they change their position in the sky. So while we're talking about where you would find them right now, if you watch this recording in a few months, you definitely want to fire up Stellarium or check in one of the periodic magazines to see where the planets will be at the time you're going to go look in the sky.
Nice.
All right. Now, Jupiter, I'm sorry, we talked about Jupiter. Let's talk about Saturn. It is big, not quite as big though as Jupiter. So we could fit 9 Earths across the disk of Saturn at the equator. And even in binoculars, what'll happen is you'll start to see in small binoculars a yellow orangish oval. But then if you have binoculars where you can throw a little more power at it, then you can start to see some separation between those classic rings and the actual planet of Saturn. The more power you can throw at it, the more detail you're going to see in those rings. Of course, now those rings too, by the way, are made up mostly of ice, little bits of dust particles as well. All right. Online, someone with the handle Smart Kid actually pointed out can actually see with their 100 by 25 binoculars. So that's awesome.
Nice.
Yeah, so that's an awesome fact that you're pointing out here. Saturn is surrounded by rings made mostly of ice, 75,000 miles per hour. That's fast.
Nice.
All right.
So does Saturn have any moons?
Saturn does have moons. They're in Saturn and Jupiter are in this eternal contest. So the moon count for Saturn is 62 currently.
Yowza.
And so I'm sure as we have more and more strong telescopes with more photographic surveys, I'm sure they'll find some more.
I'm sure they will. Now, do you see the shepherd moons in here? Do you want to talk? Do you know want to? Well,
Let's see
I've
with
got.
that one. What could you tell? I actually have not heard that term before, shepherd moon.
So
So
they
I'm
call
going to
them
learn with you.
yeah. Oh, okay. So they're called shepherd moons because it's like they're shepherding. They're clearing out a spot here in the ring. So we have Pan and Prometheus, and they are. This is a black and white image, a real image of Saturn's rings, and you can look for them in pictures of Saturn's rings. There'll be little white dots. This image was actually taken by Cassini, the Cassini spacecraft. And so if you want to
Awesome.
see a couple more of the moons, here's another picture that whoops, hang on a second. Here's another picture that I have that I don't have. Hang on. I am fighting with my program. Hang on a second. I have another.
No problem. Maybe while you're doing
Yeah, go ahead.
doing that, I can answer a quick question
Yeah, please.
that came up on the chat. So we had a good question that came up asking how many rings does Saturn have? And so that answer is a little bit tricky because it depends on how you organize them. So technically, Saturn has 4 main groups of rings and 3 that are fainter. And then they're separated by what are called divisions. And so the idea is more you can look close up at these rings, you'll start to see little dark lanes like you're pointing out with the shepherd moons. But that's kind of the general idea for the count.
Yeah. So here's another shot. This is a really interesting shot taken by Cassini as well. This is one picture. So here's Titan, and you see this blue haze? This is an atmosphere on Titan, and Saturn is in the background. So this is all one photograph, which is really cool. And when the scientists first saw this, they said, wait a minute, how do you get an atmosphere on the moon? And it's so thick that if you were to strap cardboard onto your arms and flap, you'd actually fly. You couldn't breathe, but you would fly. Um, so,
Yeah.
so, so one of the several cool missions actually have been investigating Saturn's moons over the many decades. And so you can see Enceladus here. You can actually see photographs of different Saturn's moons here as well. Did you want to mention anything else about the moons?
I just think it's really amazing to say that we could have careers being made simply on exploring one of Saturn or Jupiter's larger moons. There's some amazing things going on, and there's such a diversity in not only their surfaces, but what they're made of, and the activities happening on some of these moons. I mean,
Oh, I
when we're
know.
finding volcanoes even on moons now, that really gets astronomers excited.
It does, it does. And like it looks like a toddler got hold of a red crayon and just
It
like
does.
colored Tethys. And they don't know why or how. And then kids, as soon as they see Mimas or Mimas, you know, they say, oh, it's the Death Star. It's like, well, actually, the moon came first. It's like, where do you think they got it from? This one is coal black on one side and it's snow white on the other. And that's because of all the bug splats that you're looking at this side because it's tidally locked with, it's always showing the same face to Saturn as it goes around. And so there's tiger stripes and ice geysers over here. There's so many. If you want, it's really fascinating to see all the research that's been coming out and all of the science that's been coming out about the discoveries of Saturn's moons.
Yes, indeed. You know, we just got a really great question from Vivian asking what is the criteria that an object has to meet to be a moon?
Oh, wait, I have
And
that one. I have a slide on that one. What a
okay,
great
great.
question. Wait. Okay.
Yes.
Do you think you got all three? Here. Oh no, I've got the one for planets.
Right, for planet. Yes, you're gonna go to planet where it can clear its path and et cetera,
Okay,
et
yes,
cetera.
I have the one for planets. But not for, wait, let me see if I have the one for moons. There we go. Okay, let me move you a little bit.
Yeah,
Okay,
I
so
need to
in
move.
order for something to be a planet, this is what really got Pluto,
Yeah.
is because it has to orbit the sun. So our moon is not a planet. It has to have cleared its orbit from smaller objects, and it has to be roughly round. It has to be round. So those are the three criteria. So if an object doesn't meet these three, like Ceres from the asteroid belt, Pluto now, those are dwarf planets, and it's still kind of fuzzy whether they're dwarf planets or asteroids. So
Right.
it's just a classification
Yeah.
thing.
So what I find for the official definition is that a moon orbits a planet, but that can be a major planet like the 8 we have right now in our solar system, a minor planet, or a dwarf planet. So you'll find sometimes if we want to get away from that whole discussion, we'll just call it a satellite, right? Then of course we have to define what is that a satellite of.
Yes.
So so we could say the Galilean moons then
Hmm.
are satellites of Jupiter, for
That's,
instance.
how about this one? Dactyl is a
Right.
satellite that goes around an asteroid. In the asteroid belt, which is between Mars and Jupiter, we have a ring of rocks and dust and particles, and some of those are larger, like Ida, and the Dawn spacecraft went to go visit, and they found objects, tiny asteroids zooming around larger asteroids. So Dactyl orbits Ida, which is really interesting.
Yeah, I could see that being in an astrophysics class when the professor wants to give them a really fun gravitational problem. Say, all right, here's a 3-body orbital mechanics question for you.
Yes.
All right,
All
well, that's a
right,
good
go ahead.
question. Keep those questions coming, by the way.
Yeah, great.
All
Okay,
right.
what should we talk about now, Brian?
Well, you know, I want to point out with Saturn, with those amazing rings, the tilt of the rings actually changes depending on where Saturn is in its orbit. The orbit, by the way, for Saturn is 29, almost 29 and a half Earth years. So we've gone around the sun once and then in 1 year, that's a year for us going around the sun once. For Saturn, it's going to do that 29.45 times. This then image that you're showing, let's bring that up. I'd like that picture.
Okay.
This is showing, in case you want to set your calendar now, from starting in 2001 all the way to 2029, this gives you an idea of what the tilt of the rings will be like when we are looking towards Saturn. So right now we've got a pretty good view with the tilt for those rings. So enjoy it while you can. In a few years, they're going to become edge on, where it's going to become much more difficult to see.
Yes. Oh, and that reminds me, when they are edge on, I don't know if you've noticed this in Stellarium. You notice how the moons are like all over the place? And when we went
Yes.
to Jupiter, they you could actually, when you look at Jupiter, let me zoom out so you can we can recap where we've seen these. Okay, here's Saturn and then here's Jupiter. If we zoom into Jupiter even with binoculars, I'm going to notice that these are pretty much in a straight line. Not perfect, but pretty much in a straight line. Saturn isn't like that unless the rings are edge on. And then that's at a point where you will be able to see those moons that line up pretty much with the rings. So they're all going to be, you see how they're like all over the place? It's because you're
Awesome.
looking down at
Yes.
the plane.
Well, that's a good thing to point out. I like that.
Yeah. All right, go ahead.
So, all right. David Majors went where I wasn't going to go, but I'm kind of glad he did. One of the criteria for a planet being a planet is that it clears its path. But technically, Jupiter wouldn't be a planet by that criteria because of the Trojans and Greeks, which
Yes.
are all kinds of other asteroids that are before and ahead of, I'm sorry, ahead of and behind Jupiter.
We have all kinds
So,
of problems if we don't call it a planet, though.
yes, oh, I agree. Well, that's the thing is I'm sure eventually they'll have another
Another
International
designation.
Astronomical Union meeting and like, all right, we need to fix
We
this.
need to fix
So
the
thanks a
problem.
lot, David, for opening that can of worms. And and David, do want to thank you and Thomas. You guys are adding great questions and answers to the chat. So thanks for that.
Yes, thank you.
All right. So a couple of things. Let's talk about Saturn. I think I'm almost done.
Yeah, go ahead.
I want to point out that Saturn, like Jupiter, is mostly hydrogen and helium for its atmosphere. Remember, it is called a gas giant. Length of the day, by the way, is a little bit longer. It's about 10.7 hours, but we're actually not completely sure. Imagine it's a little bit difficult to measure something that's a gas mostly on its surface to say, well, when is one rotation fully accomplished? So I think
Awesome.
that's all I have for Saturn.
Awesome.
Anything else
Yeah,
that you can think of?
I wanted to actually share some images that our members have taken of these planets. And so when, excuse me, when I was preparing for tonight's presentation, I reached out and I said, does anybody have any great images? And people sent me, our astronomers actually took these images very recently. So I wanted to share those with you. So let me go ahead and bring those up, and they're going to go right on to, this isn't, this is not a member picture, but let me show you those right now. And here we go. So this one was taken by Lee Coombs, and obviously the planets are not really here. So this is Jupiter, Mars, this one looks like a penny, and Saturn. And so he just simply put these three together so they would all fit on the same slide. And these were taken with a 6-inch f/12 refractor. So it's a 6-inch refractor. So a dollar bill is 6 inches across. So 6 inches means that the telescope itself, the opening at the end, or the main primary mirror, is 6 inches. So it's not that big of a telescope. And a lot of people say, well, what kind of telescope do I get? Well, it depends on what you want to look at. Refractors are really, really great for looking at things like moons. I'm sorry, things like planets, well, and the moon. Okay, and so he actually has, he took a number of pictures, ISO of 800, if that means anything to you, and he stacked them together, and now he has these gorgeous pictures taken from his backyard. And he didn't have any super fancy equipment. It was just a telescope, a camera, and a little bit of patience.
Yeah, that's a really nice picture. I really like that. Just shows how diverse the planets in our little solar system are from each
Yeah,
other.
yeah, very much.
All right, awesome. Any other images you wanted to
Oh
show right now?
goodness, I've got some deep sky images. Did you want me to share those now, or?
I'm thinking maybe we're going to do deep sky soon. We still have a couple
Okay.
of the planets I was going to
Yeah,
bring up.
you
What
were
do you
gonna.
think?
Yes, yes. Let's go to the
Okay, awesome.
other planets. Okay, go ahead.
I did want to bring up another great question that came up
Hmm.
online. And the Papa Alpha had asked, are the rings tilting relative to the planet or as the system tilted from our perspective? And so I think a good way to, as I understand it, to explain that is Saturn itself is tilted 27 degrees on its axis, and then it's orbiting around the sun. So, and as far as I know, I do believe the rings are more or less over the equator of Saturn. So they
Hmm.
also have that tilt.
Hmm.
So then as Saturn is orbiting around the sun, from our perspective, it's showing us a different perspective of that tilt in order to show us that different angle.
Yes, it's the same reason that the Earth is. I'm sorry, I just just put you back on. It's the same reason that the Earth has
Hello.
seasons. Hi. So it's the a lot of people actually get confused about why the Earth has seasons, and they think it's because we are closer or
Right.
further from the sun, and it's not. It's because of the tilt, and every planet has their own unique tilt. Uranus is tilted way over. And so it just depends on during the formation process of the solar system. But it's the tilt, and so as it travels around the sun, it's going to have different parts exposed to the sun for different lengths of time, and that's what gives us our seasons.
Awesome.
So yeah,
So these are
yes,
great questions
these are really
tonight,
good
everyone.
questions. All
All right.
right.
Well, we've talked about the gas giants. Let's come a little bit closer to our neighborhood of the solar system. As Jupiter and Saturn aren't the only planets that are easy to see right now. Mars and Venus are also quite prominent in the night sky. Now, Mars, we'll talk about that one next. That one's visible at sunset, although much farther along the ecliptic. See Venus, we're going to have to get up pretty early or stay up really late. And we'll talk about Venus in a minute.
Okay, do you want me to show where
So,
they are? Do you want me to do that first?
yeah, let's do that.
Okay. Okay,
As you're bringing
so
that up.
yes. Okay, so we
Zoom
are
out.
going to zoom out and let me get rid of all the
And then
lines. Go ahead.
perfect. And let's look really quick and notice Sagittarius. Sorry, as you've already moved the sky.
Okay.
Such power you have
I
moving the
do.
sky like that, Aurora.
It's really fun.
If you start at Sagittarius, you follow the ecliptic,
The what?
which would be the ecliptic, which is our view looking towards the plane of the solar system and also, our galaxy for the most part, but we'll talk about that later. And if you follow that, then that's where, by the way, if you're looking at the constellations that would be considered the zodiac, those constellations are more or less along that imaginary line across the sky. So from Sagittarius, we would go to Capricornus.
Well, hang on.
Yeah, we better
Just in
turn on
case
some lines,
people,
huh?
yeah, if
There
people
we
don't
go.
know where things are.
Perfect. I like
Okay.
that.
Okay. So we're at Sagittarius. We're
So
at the teapot here, and then this is the ecliptic. This is the plane that everything is in. Well, every more or less is in. The
more or
planets,
less, yeah, exactly.
more or
There's some
less.
that don't follow the rules.
Yeah, but you can see there's quite a bit of deviation. So if you look up at the sky during the day and just notice how the sun goes, it traces a path through the sky, and then if you notice the moon also traces that a very almost exact same path. So the planets also follow that same path, more or less. And we call that path the ecliptic. And it's because the solar system is in a plane. It's like on a sheet of paper. And so everything lives more or less just above or a little bit below that plane. And so everything operates in that. And so it's really easy to find the planets because if you kind of notice during the day, okay, the sun is a little bit low, it's over here. And that ecliptic is going to appear differently depending on what season you're in. Winter, spring, summer. You're going to notice the sun sets in a different place depending on if it's December or if it's May, unless you live on the equator. And so, so that's what we're talking about. So if you want to try to find the planets, you just look at the ecliptic, that path that moon and the sun trace during the daytime and evening for the moon, and you're going to be able to find those planets. And so that's what he's going to be talking about. Okay, go ahead.
So that would mean, Aurora, that there'd be no reason if we're looking, let's say, towards the North Star, don't try to find a planet close to that area of the sky.
For us,
Right?
right? We're not
Right.
going to find anything.
Yeah.
So here's
Okay,
north.
good. Thank you for bringing some more description to that ecliptic.
Yeah.
Yeah, that imaginary line will come in very handy when you're looking for the planets. So if we're following along, then we have Sagittarius, then Capricornus, Aquarius, and then finally Pisces, which is the fish.
Yes.
And then, or we could also just say, look to the east and look up from the horizon and that really bright red thing. That's Mars. That's another way you could find it.
That is, and it is really red. You know, Kent talked about this last time, and you just basically, like, as soon as we're done tonight, go outside, look east, look up, and you're going to see something big and red, and it orange. And it really does look like that. And if you put your binoculars on it, it'll look like a fuzzy red patch. It'll kind of look like that. And so it's not going to look like a gorgeous picture like you see from the Hubble Space Telescope, which I will bring up here in just a second. It's not going to look like that, even though people in the media says, oh, it's the closest it's ever going to be in 26 years. Well, we still have an atmosphere we're looking through, and it's still really far away. So this is not a picture you're going to get from a pair of binoculars. But this is a real picture of Mars. This is taken from a presentation I did on planets for some students. And so you can actually see this is a picture you can get from NASA. You can get this when you have really great pictures of Mars. Something else, Brian, we actually have really cool pictures. Do you know what this is, Brian?
Yes, and we just got the question about retrograde motion.
Oh, you're kidding.
On the chat. So
okay, retrograde motion. So all the planets appear to retrograde from Earth. It's not just unique to Mars. So if you've ever been in a car and you're going around a turn, and even though both cars are going, if you are on that inside turn and if you're both going the same speed, because you have less to go in that turn, right? Because you have a shorter amount of distance because you're on the inside track, it's going to appear, if you look out of the corner of your eye, they might appear to slide back. And then they're going to appear to, they step on the gas and then they're going to go forward. So the planets, because they're all on orbits and because they're all on these circular racetracks around the sun and because they all go at different speeds, they appear to sometimes speed up, slow down, go backwards, and then go forwards. And that's not what's happening. It's an optical illusion. It's because of where we are and where they are and where we are on the racetrack. That's the easiest way I can think of to describe it.
That's an awesome explanation. I have a little video from NASA that shows an animation.
Great. Let me pull you up. Hang on. So yeah, each one of these dots, this isn't over one night. This is, you're taking a picture one night, then the next night, and the next night, and the next night, and then you're adding up all those dots together on a piece of film. That's what that picture is of. Oh, and the other question that came in, this is the sand dunes here, and these are two of the moons. And this is a volcano that blew itself up so fast, it sunk itself into the surface. And so it's not a crater, it's a volcano. Okay, so let's go and look at your animation. Okay,
awesome.
All yours.
All right, thank you. Make sure that I optimize for video clip. So let's get, we'll get a perspective here. White in the middle of these two circles is the sun, blue is Earth, red is Mars. And then in this green square down on the lower right-hand side, that shows the view that we would have from Earth. So that we can watch that and see the orbit of the two planets and then what Mars appears to do when we're looking at it. So you can see it's moving east. And then as we start to overtake Mars, it appears to go backwards and then traces itself back in the sky. And then as Mars starts to fall behind, then it starts to go the other direction again. And there we have it.
That's awesome. I want that animation for my class. That's wonderful.
Yes, I will send you the link. And if you'd like to find it, in fact, what I'll do is I'll put the link in the chat. Also, that way everyone can get at it easily. And let me go ahead and stop the share.
Oh, okay.
Great. Yeah. Okay. Awesome.
Perfect. All
Okay.
right. Did you want to talk any more about Mars or answer any more
I
quick
do.
questions? Okay,
We
go
could
for
talk the rest of our time, right?
We
about
totally
Mars.
could. There have been so much great stuff about Mars, but go ahead. We have other things
Let's
we need
talk
to
about
cover.
the size a little bit. We'll give ourselves some perspective. Now, let's say that the sun in the middle of our solar system was about the size of a typical front door of a house. By that size comparison, Earth would be about the size of a dime, and then Mars would be about the size of an aspirin tablet. So much smaller.
Wow.
Now, Mars is not going to do well if it tried to be in the contest of moons between these other planets. Mars has two, Deimos and Phobos, and they're quite small and actually orbiting fairly close to the planet. So this would be a little bit harder for, I wouldn't try to see those in binoculars, that's for sure.
No.
And now, where's the name come from? Mars, actually, that name comes for the name for the Roman god of war.
Mm-hmm.
And let's talk about year and day, I should say. It takes Mars about 1.88 Earth years to go around the sun once. And the day is actually pretty close to us. It's just a little over 24 hours. Now, part of the reason why we like to go to Mars is it's much closer than the other planets. It's actually just 1.5 astronomical units. So reminder, astronomical unit would be 93 million miles for us between the sun and the Earth, but then 1.5 for Mars.
Nice.
All right.
Okay, that's awesome.
So David pointed out the good question. He's helping relay these. Thank you for doing that. Smart Kid had asked if Phobos and Deimos are going to break up.
Yes, they are expecting the one that's closer in, Phobos, because it is experiencing such strong tidal forces, that it's either expected to break apart and become a ring around Mars, or it'll be like the worst meteor impact ever. And then everybody will have a piece of Mars because it'll be flying all over the place. Don't know, and we have no idea when. but yes. They do recognize that the tidal forces are really, really strong on that particular moon. It's also slowly spiraling inwards towards the planet, and it's orbiting faster than it is going around. So it's orbiting twice as fast than Mars is rotating, and those things combined really stress out the core of Phobos. So, so there you have it.
I don't know. I wouldn't hold your breath, but yes, probably gonna crash.
Probably gonna crash. Just it's a matter of what kind of crash, what flavor crash.
Yes. Excellent.
Awesome.
All right. One last planet to talk about.
Ooh, wait a minute. Let me guess.
Oh, what could it be?
Did you know that for a long time we did not know? We actually thought there was a planet closer in. Look at this picture that I found from 1846. So here's the sun. Here's Venus, Earth, Mercury. Look at this.
Oh, Vulcan. Appropriate name.
I know. I kid you not. They actually thought another planet was closer in. And my personal theory is because anytime you look that close to the sun, you're going to see spots.
Yes. Right. Exactly. Yes.
So
and you'll see it long after you've stopped looking at the sun.
Yes. So don't look at the sun. But a French scientist in the 1860s, he published a paper. There was this weird thing about Mercury's orbit. They didn't think it followed the right way that it should. And so people thought, oh, I know, there's another planet closer in between the sun and Mercury that's yanking on it. And so they figured that had to be it. But actually it turns out that, well, they had an error in the way they modeled the path of Mercury, and some of their math wasn't right, and so now we know there really is not a planet there. So closest planet it is Mercury, but it's not the hottest planet, is it?
No, it's not.
So this planet that I think you're going to reveal, that I think most people have figured out, it's the only one named for a female. It's named for the goddess of beauty and the goddess of love.
Yes.
We didn't know about the 900-degree surface temperature that
No, we
melts
didn't. It is
cannonballs.
not a loving atmosphere.
The atmospheric pressure that crushes any spaceship. You know, the lethal carbon dioxide atmosphere, the sulfuric acid rain clouds. You know, it's probably good we didn't know that. We might have named it something worse.
Yeah, probably Hera, right? The vengeful
But that's still
wife
female.
of Zeus.
Maybe they did know about women back then. All right,
Yeah.
so I'm just kidding. Okay, so go ahead. Tell us about this planet. Let me get a picture up for you here.
Excellent. Yes. All right. Venus. Now, for this one, this is either a morning or evening object, depending on where Venus is in its orbit around the sun. And
Okay.
for right now, if you look at this time of the year, if you look to the east about an hour before sunrise, so we're talking like 4 or 5 in the morning, look for that really bright object towards the east. If you're familiar with Leo, which we've talked about before, that question mark, and then the brightest star in Leo is Regulus. You could either start from Regulus or go lower and then just follow Regulus down, I guess I should say. And then Venus will be just down and to the left. So we're gonna have to.
Oh, did I
we have
change
to
the
advance
year? Hang on. I thought I advanced it to the right.
Might need to go closer to 5 in
Yeah.
the morning.
Let's see. Whoop. There it is.
There
Perfect.
it is.
Okay, so
Yeah,
5
see,
o'clock this morning. It's pretty low.
Yeah, very low.
Okay.
I remember years ago, really, if I'm honest, decades ago, I turned binoculars towards Venus and thought my binoculars were turned around backwards and I was actually looking at the moon because I was looking at an object that had a phase like the moon. In other words, it wasn't a solid disk. Venus has phases, just like our moon does. And in fact, right now, Venus is just about 3/4 full. So that's one of the fun things that you can do is with a good pair of binoculars or definitely with a telescope.
There you go. That's
Awesome.
what it
There
looks
it
like
is.
tonight.
You can actually see that only part of the disk is illuminated.
Mm-hmm.
All right. Now, boy, what else do we have to say about Venus?
Why does Venus have phases? It's a good question. It's because it's an interior planet. So you're not going to see phase. If you can imagine Venus, like the sun being the big bright light source that it is. And at sometimes it's just like our moon. Sometimes our moon is going to be, it looks like it's disappeared, right? You can't see it. It's because half of the moon is always being illuminated. But depending on where it is, if it's between the sun and us, it's going to illuminate a side we can't see. And so it's going to look very dark. But if the moon swings around behind us and the sun is in front of us, we look back, oh, we can see that whole disk lit up, right? And we call it a full moon, even though half of the moon is lit. Same thing is going on with these planets, as depending on where they are, because of our position and because they're interior planets, we're going to be able to see, with Venus, I don't think we ever see the full thing because it would have to be on the other side of the sun. So we can see a lot of it, and then and then we can see it kind of, let me see if I can advance it a little bit. But you keep talking, Brian. We can see it going between its phases.
Okay, awesome. We actually got a good question online asking what color is Venus actually supposed to be? Is it blue or brown? Different pictures tell different tales.
Yes, they do.
Go ahead. Officially, we'd probably say it's either white or slightly yellow as we're looking at it. But remember, sometimes when you're looking at astronomical pictures, scientists are using what are called false color, where they're actually using a computer to generate an image to show us different features about the planet that may not even be available in visible light. Mm-hmm. So, and this would be an example. Yeah, here's one where Venus is blue.
These are both pictures of Venus. And so this is the coat that you can see here. Like Earth and Mars and Venus, they're all bathed in a flow of plasma that comes from the sun called solar wind. And the Earth has a magnetic field that acts like an invisible coat to protect the Earth. and it deflects the solar wind. But Venus and Mars don't really have coats, so they get blasted by that solar wind. The solar wind's not really wind, not like, right? There's no air in space. But it's a stream of particles, highly charged particles that are coming from the sun. So this is an image that they took to better visualize what that flow of particles looks like as it gets blasted. So the sun would be over here, and you can see it kind of looks like a baseball if you put it in a stream of running water. You would actually see it zooming around either side. And so here is a real picture of Venus. Oh, and so the factoid that's on this slide is a day on Venus is longer than a year. And so if you think about that, it's like, how can you have a day longer than a year? So Venus, it takes, oh, where's my ball? Here we go. I have it. Okay. So it takes Venus longer. A day is this, right? When you make one turn on your own axis. Right. And a year is if we have the sun here and it goes around once. One trip around the sun is a year. So it takes Venus longer to do this than it does to do this. And so and not only that, it's doing that backwards. So.
Yes. This is all kinds of screwy things going on.
There are. Did you hear about the latest thing with the,
yes.
You did,
phosphine.
Yes, the phosphine. So that was really interesting. Did you want to summarize that real quick, or do you want me to?
Well, I guess I would start by saying, right, so they discovered this compound, right, or this molecule phosphine, and one way we know that can be created is through volcanic activity, which we're not aware of currently on Venus. Or the other way, Aurora, you can
go ahead.
Share the name. The other way is from life, from bacteria and such. But that becomes a really fun mental exercise when you have a planet that's mainly carbon dioxide with clouds of sulfuric acid droplets in it.
Yes, and so they're still trying to puzzle things out, and so you can look for more information on that. And they didn't.
And you can be sure that there are many new Venus missions on drawing boards in many a space agency.
Yes. Did you want to share anything else about Venus?
That's what I have for Venus. I think I'm about ready to talk about a couple of deep space objects.
Okay, let me give everybody a quiz real quick. You guys ready? Quiz time, here we go. Here, quiz time for Aurora. Can she show the right? There we go. Okay, so here we go. Let me turn off the planets, and I am going to change the time back so it's 9 o'clock tonight. And there we go, 9-ish, 10 o'clock. Okay, and so here's what we're going to do. So I'm going to zoom out, and we're going to see some stars, right? Whoops, without the lines. Okay, I want you to see if you can tell me, we didn't actually talk about this particular constellation, but I want to see if you can start to find a couple of things in the night sky. So here, let's look here. Go back a little bit. Okay, so we are facing north here, and what's really cool about this, if I put these on, let's see if I can get to a good, oh, you know what, let me turn off the sky. Okay, so I have my, where is your, this will lead into what you're going to do next, Brian.
Awesome.
Okay, so here we go. We are in the night sky. Let me orient this better. Here we go. Okay, so here is our horizon, and we have a bunch of stars. Can you find the Big Dipper? You see anything that kind of looks like it could be Big Dipper-ish? If I give you a little bit of a hint. Oh, whoop, look at that. I made it disappear. Hang on, let me try this again. There we go. Do you see, let me turn this off. Do you see anything? There it is. Do you see anything that looks like a Big Dipper? You see anything here? Okay, so we have some handles, we have the bowl, right? So we have the Big Dipper. Most people can find the Big Dipper. Finding the Little Dipper is trickier. So let's see if we can find the Little Dipper. Okay, so what we're going to do is, in the Northern Hemisphere, the Big Dipper is up most of the time. It's up just about year-round. And so you want to connect these two stars of the bowl. Here, if we connect the bowl, you can see how they're connected. This is the whole constellation, the Bear. But if we connect these two, it's going to take us to the tail end here. And we can see this is the Little Dipper. And one of the things I wanted to point out is this is that North Star Polaris. All the other stars rotate around this star. And so you can actually see if we speed up time, this star doesn't actually move. Here, put it here. But all the other stars, so we're going at a rate that normally stars don't progress at. This is a lot faster, but they're all orbiting. It looks like they're orbiting this star. They're not, but it appears that's because our North Pole is aimed right at this star. Now, it's not always aimed at the North Star Polaris right now. It'll be aimed at a different star. Okay, so let me pause it because I think it's about to be daybreak. Okay, so now do you see the Big Dipper again? You see it over here? Okay, now here, I'll turn this off. Can you find the hand? Here, I'll mess it up. There we go. Okay, find the Big Dipper. Now find the Little Dipper. So connect these two stars. It's in a different orientation. That's going to happen throughout the year. Sometimes it's going to be emptying out the contents. Sometimes it's going to be looking like you're going to pour something in. Okay, so you're going to take these two, and then you're going to connect it. This is the tail end of the Little Dipper. You see that? Okay, why am I going on about this? Because Brian, is this your next constellation, Brian, with Cassiopeia?
It's like Taurus, or are you pointing? Where are we? I'm upside down.
You're upside.
Oh yes, Cassiopeia. Okay, right.
Okay.
I just saw the triangle.
Sorry, I should put
yes,
the time
indeed.
back. Yes, we are upside here. I will write that.
I mean, of course, that still works. That's a fun thing. That'd be fun is just like, shake yourself around and then go look outside and see if you can orient yourself to the time of the year.
Yes, very much. Okay, so if you can find the Big Dipper, you can find the Little Dipper, and then you notice if you go over one more, you're going to have this mountain-looking one here. Do you see that? If we take the stars away, here's the Big Dipper, which is easy to find. We're going to connect this to a bright star. That's the Little Dipper, and then go about that distance again. And then you're going to see some stars that look like two little mountains, two little triangles. Did I get out of order, Brian?
Yes.
Or we?
Perfect. No, that's great.
We did.
Yeah,
okay.
that's great.
Okay, I'm going to put the time
Awesome.
back. What do you want to talk about Cassiopeia?
Yeah, so let's talk about Cassiopeia. There's one of the most awesome objects to look at. And if you're lucky enough to be in some dark skies, this is a naked eye object. And I want to point out, we've been talking about objects in our solar system. So these were all planets that are orbiting our sun. Now we're going to go very far away, light years and light years, to talk about a galaxy. This one's called the Andromeda Galaxy. Has a couple other names. One would be M31, which was 31st on Messier's list. And we can talk about Messier if we start getting that question. And then in the new general catalog, or NGC, it's NGC 224.
Okay.
Now, this amazing galaxy is actually located in the constellation Andromeda. But I think it's easier to find, as you pointed out, Aurora, by looking for Cassiopeia that is either an M or a W or something in between.
Or 3.
Depending on or 3. Yeah, I was going to say it's closer to like a 3. And if you start from those top 3 stars in that triangle, they can act like a pointer. And if you head towards the great square of Pegasus, which we can pull out and look at, Pegasus, now a whole other constellation, look for that nice giant square. Go between there, and then you'll actually see a faint oval when you look with binoculars. And that little oval is an entirely separate galaxy. And that's the Andromeda Galaxy.
And it's actually a naked eye object. If your skies are dark enough, you will not need a pair of binoculars, but it looks better. In binoculars, it's going to look like a smudge. It's going to look pretty much like that. Well, actually, it's going to look like that.
Yes.
In a telescope, it's going to look, well, it depends on your telescope. It's going to look like that. In a 14-inch, maybe like that. And in Kent's telescope.
Right. Yes, you get to a 20-inch.
And this is what it's going to look like when you do some astrophotography. You're not going to see these colors when you are looking through a telescope. It's going to look like a greenish smudge. It's because the film can record so many more wavelengths than your eye can see. So,
Aurora, I'm thinking if we could zoom out a little and show where Merak is, You notice we've talked about completely separate constellations, Andromeda and the Great Square of Pegasus. Mirac is right below Andromeda, the bright one, in part of those three that form a trail. Perfect, right there. Thank you. Uh, Whenever we're looking for deep sky objects or really even planets, we usually aim for the big, brightest stars because those are going to be the easiest to see regardless of the seeing conditions. So that's why I like talking about Cassiopeia and the Great Square of Pegasus. But if you can see some other stars, there's other ways to find it. Now we have another constellation called Andromeda,
Mm-hmm.
which is actually where this galaxy is located. And one of the brightest stars, if not, I have to check and see which is the brightest, is Mirac. And Mirac,
I think there's
then,
one brighter, but yes, go ahead.
okay, thank you. Yes, so one of the brightest at least. Thank you. It actually, if you start from Mirac, you could follow a little trail of two other stars straight towards Andromeda. And you can also do something, by the way, when you start to find fainter objects, you can do something called star hopping, which I know Kent has talked about before.
Yes.
When we start for those really faint objects, you may not be able to even see the star naked eye. So this is a good one to practice star hopping, as you have three nice bright ones. So put Mirac in the field of your binoculars or telescope and then hop over to the next and on until you see the galaxy.
Nice. Yeah, we
All
actually
right.
covered Andromeda in detail. I think it was last month or the month before. So if you
Okay.
wanted to go back, and you can go to
Yes.
centralcoastastronomy.org and take a look at that information. Oh, I should
Perfect.
do that. Hi, this is Aurora with Central Coast Astronomy. I know people hop on and off. We're doing
That's right.
we're doing
What is this
stargazing.
wonderful show they're watching?
I know, and I took off the little thing on the bottom. So here it is. So we're doing stargazing for tonight, and we are answering questions live. So if you have any specific questions, we've been focusing on really bright objects you can see. We've got a few more to share with you, and then we're also answering the questions as they come in. And then we're going to answer equipment questions. I have some downloads I want to show you. Oh, is now a good time, Brian, to tell them about the other charts that I have here?
I think that's a very good time. We have one object left, but before we do that, I think it'd be great to talk about some of the other resources
Okay. That
and
sounds
such that you
great.
have.
Yeah. So one of the great things about this is it's paper and it won't ever lose batteries. It's also hard to see at night. And when you want to stargaze, the last thing you want to do is put a bright flashlight on a white piece of paper and then try to look up and see stars. So one of the things that people have done is they'll use like a phone app. And so phone apps typically the good ones will go red. And so that will help save your vision. By only engaging certain wavelengths for you to look at. And the great part is the app can actually help you find things in the night sky that could otherwise be a challenge. The downside, one of the downsides of using an app, other than your phone battery going dead, is it doesn't show you the progression. So during the year, you don't know, is Mars rising a little bit later every day? Is it a little bit earlier? And so it can be hard to get the big picture. It's like being zoomed in, like with a microscope. So what I found really helpful, and these are only like $4 or $5 from Sky and Telescope, is the Sky Gazer's Almanac. And I have these up on the wall. My kids look at these things all the time. And I'll ask them, okay, so who's up tonight? And they can, in one glance, just look over, find the date. So it's January, February, March, all the way down. Here's June. You see the nights of June are very short. And all the way down to December, the nights are very long. So we can see in here, and we'll say, what is today? October. So October, and I can start with October, and I can read this chart along here, and each one of these colored lines is a different planet doing a different thing. It could be transiting, which means it's overhead. It could be rising. It could be setting, and everything is matched to a time. So we have the date here, and we have time in hours. We have sunset, and then midnight, and then sunrise. And meteor showers are on here. It's just a really good resource. So you can kind of see, like, throughout the year, you're like, wow, okay, that makes sense. And so the way, it's another tool that's really inexpensive that you can use. It's not in digitized format. You've got to actually buy the thing. So that's another really good resource. Another one is the actual magazine itself from Sky and Telescope. There's Astronomy magazine. I don't have one of those. I think I subscribe to both of them. And what's really neat about these is they also come with monthly star charts in them. And as we showed you before, it also comes with a the star chart for, it used to have Saturn. I don't know why they don't have them anymore, but they have Jupiter, so you can tell which moon is which on a particular night. And so that's another really great resource. And it's inexpensive. You can also get them in digital format as well. So those are two resources that I was going to share. I was going to wait to answer the equipment questions. If you would like, and if you've already familiar with the night sky, you've been joining us and you're ready to maybe find a couple of more objects on your own, more than we're doing tonight, I would encourage you to go back to last week's, where Kent and I are doing stargazing. And we did a huge stargazing of astronomy in Halloween-themed astronomical objects. And so it's like a 28 or 29 page document. And we actually didn't get through them all because it was really long. So we went through the first 12 or 13 objects. And so you can look through this as well. And we go into detail about each one, about where to find them, what they look like, where to look in the night sky. Kent actually corrected me. I actually did some internet research and looked through some books. And what's really amazing is he said, actually, Aurora, that's not correct. It's been printed like that for years. Here's the original paper and here's the real data. So he went through, so the stuff in here is the best knowledge that you can get. And he actually goes back and he will correct computer programs and he will edit textbooks for people solely out of the knowledge from his head. So you won't find a better expert, especially in planetary nebula. So that information is available on the website. Our website is www.centralcoastastronomy.org, and you just you click on the one that says Halloween Stargazing, and you can download there should be a button to download the document. It's yours free, and just go out there, and we just want you to get stargazing and just get excited about the night sky. Okay, let's see other questions that are coming in. Do you want to answer? Oh no, wait, we have a deep sky object we have to show people. I got sidetracked. Are you ready?
That's fine. We have one more, but that's all really good information.
We're on our way there.
Yes. I want to mention, because this question came up as a text message, they had asked about the sky map. This is available free. I want to make sure they asked where they could buy it. Remember, we want to point out this one is available free, and I've posted the link in the chat, and each month they update it. And don't forget those amazing list of objects each month too.
Oh, yes, on the back, aren't they?
Yes.
Yes, very good.
All right. And B Meets asked if precious stones can be found on asteroids. And yes, that is very possible. And also gold.
Yes.
There are actually companies formed right now where their mission statement is to be able to mine asteroids.
Yes. That's just amazing. And NASA has been finding impact craters. They're actually finding nanodiamonds from the impact of the things slamming, getting really hot. And if you've got the right molecules in the right order, all of a sudden you have diamonds at crater sites. And they're also one of the, did you hear about the raining Neptunes on raining diamonds on Neptune?
Raining diamonds, yes.
Raining diamonds, and
amazing.
not
what a
like
crazy solar system.
We have a crazy, wild solar system. So there are no current missions to Uranus or Neptune, and they to mine anything. It's just too far away. Your spaceship would take over 20 years to get there. But scientists think there are these tiny little precipitates of diamonds that possibly might be in the atmosphere. We have no idea. So it's just one of the many ideas.
Yeah. Sometime, Aurora, I think for a special could be to talk about stellar cycles and how stars finish up their lives with the pressure they're under. Some of theirs, they're thinking there may even be carbon diamond collapsed stars out there.
Yes. Or how about that one with where the star actually exploded that was inside of another star?
I haven't seen that one.
or the one where the white dwarf, after the one has already exploded and it turned into a white dwarf, but it's smaller than its planet. And so the sun is
right.
So it's like the planet's 7 times bigger, and it's going once every 30 hours around this teeny little star.
Yes.
So
maybe we can have a talk about the really odd ones out there.
Really strange ones. Okay.
Hey,
let's go back.
One last object.
Yes.
Yeah, one last deep space object. This one I really like to bring up, Aurora, because of the fact that it's often mistaken. Often the Little Dipper is sitting just minding its own business, and people will look elsewhere and say, hey, there's the Little Dipper. But they're not actually looking at the Little Dipper. They're looking at the Pleiades. So this object we're going to talk about would be called an open star cluster. There it is. That's a nice picture of it. I really like how Stellarium will actually give you a photographic image of these objects when you zoom in.
Mm-hmm.
Pleiades right now rises at about 7:30 in the evening, but you're really going to have to wait until 9 o'clock or later to see it well. And this is another naked eye object. And part of why it's sometimes mistaken, when you look up in the sky, I should say mistaken as a Little Dipper, is it almost looks, if you look at how it is, if you imagine the scoop at the top and the handle coming down, people will think it looks like a dipper, but this is much smaller than the constellation Ursa Minor. And how do we find this one? Well,
Okay.
really, you can just start looking to the northeast for a fuzzy spot, but I'm going to give you a little bit more than that. Now, you can see right about in the center, and below where Pleiades, right where where Aurora is circling, there's a red star, and then you see that triangle, which is the head of Taurus. And if you look later in the evening, you'll be able to see Taurus, and there definitely see the drawing depicting. These drawings are really handy because oftentimes we look at this constellation and it's like, how does that look anything like a bull? Well, it's like, okay, now we can see it's a head.
The eye of Taurus, that red eye there.
Yes. Now, when you're looking that way, you can look for that bright red star, Aldebaran, I believe,
Mm-hmm.
right? And then the head of the bull,
Mm-hmm.
and go up, and then you'll find that fuzzy spot, Pleiades, which is that open star cluster. But I definitely want to share another way you can find it, and we'll need Perseus in the view for this one.
Okay.
Um, if and when Pleiades is lower in the sky, you're not going to be able to see Taurus yet. So here's another fun way to see it. If you're looking to the east northeast, and then you will see the constellation Perseus. Now, when I see Perseus, I think of an outstretched hand that you're looking at from the side.
Mm-hmm.
And so if we're going to bring up, yeah, so we could see as far as the drawing goes, then Perseus there has poor Medusa's head. Don't know what she did to deserve that, but there's
We actually
Medusa's head.
covered Perseus last
Yes.
month, so you can
Right.
always
And
go
of course,
back.
we could watch Clash of the Titans if you want to know an
Ooh,
altered
I never
version
liked
of that
movie.
story.
Okay, so tell us more about Perseus, or tell us how
So
to locate it.
yeah, so if we're looking at Perseus with the wrist towards the top as an outstretched hand, and then you have the thumb, it's as if Perseus is saying as a hand, here's Pleiades, right off the fingertips, and bam, there it is.
All right, let me turn
Now,
off the constellations so we can try it
okay.
ourselves.
Yeah.
So here we go. So I'm going to move things around. Okay, we're going to go east. And so we're just looking east, and we're going to go up. And I can see this red dot. I see a triangle. And up here, this is the first way he mentioned how to find it, would be Pleiades. Okay, now see if you can do it the Perseus way. Okay, so here, let me get that in there. Okay, do you see the outstretched hand that he was talking about here? Do you see that in Perseus? And it comes right off the tip of the finger, and boom, there it is. You see it? So here. Okay, close your eyes. I'm going to jiggle it. Okay, now you do it. Okay, let's see. I should just advance the time. That would really mess things up.
Oh, yeah, that's a good idea.
That's a good... No, I'm not going to be that mean. Okay, so we're looking east. Okay, go ahead and find M45, which is Pleiades. And while you're doing that, I can just tell you that you don't really want to use a telescope on this one. It's too big. This is a perfect naked eye and binocular object. And so the darker your skies are going to be, the better it's going to show up. It's just going to look like diamonds. And if you have really great seeing, if it's really clear, you'll be able to see this nebulosity here. And so Kent and I actually are going to cover the Pleiades soon in a future stargazing event, or a future star session. Yeah, stargazing event. And so it's really cool. And we're
Excellent.
actually,
I look forward to the knowledge nuggets that he'll be able to impart.
Yes, I was going to share some, but I think I'm just going to wait because I want you guys to get the full effect.
Yeah, I
from
think
Kent.
I'll wait too. I have a few others, so
Go
stay
ahead.
tuned for a future episode for more details on Pleiades. But at least now, when you're looking up, just don't call Pleiades the Little Dipper. Poor little
No.
Ursa Minor.
Delphinius is
We'll
the
get
other
jealous.
one that people confuse with the Little Dipper.
Which one?
Delphinius. Let's see if I
Oh,
can
yes,
find it.
Delphinius. That makes sense.
Let's see. Where is it? No, not that one. Here, I'll find it. But okay, did you want to answer a couple of questions and then we'll move on to equipment questions?
Sure. Very good. So we had Stephen asked, where do we look to see the center of our galaxy? And so
That's a
thank you,
great
David, for
question.
answering that. Also, we'll answer it on the screen. So we've actually showed that area of the
Yes.
sky.
Yes, we
Look
have.
towards Sagittarius.
Okay, now where was Sagittarius? Oh no!
Where was it?
It's got to be here somewhere. How about we go a little bit more towards the south? If we take away this, okay. And what do you see here? Do you see anything you recognize? You see really bright stars that aren't really stars. If I put the names of them, maybe that'll help. We've got Jupiter and Saturn. And that means Sagittarius is right below us. That teapot is pouring steam, and you can actually see the Milky Way coming up and out of the teapot. Brian, what's the shortcut for getting the Milky Way to show up?
That's let me see. I'll pull it up for you. I have to.
I accidentally turned it off
Sky
because
and
I
Ju-
wanted you guys to see the stars more clearly.
Well, how I do it is if you go to the cartoon bubble with the planets in it, the third one down, and on the left there, and then it'll be the top left choice, Milky Way brightness saturation.
There we go. Okay, there we go. So the center of the galaxy is going to be right in that Milky Way. And so you can see, if we put this...
I wish it looked like that where I was.
I know. I bet Dave Majors has seen it this amazing, and I bet Kent
Yes.
has, and Lee. And actually, this is a perfect opportunity to shift gears and show you some astronomer pictures from the Milky Way. Can you find Sagittarius in this picture? Let's see if you can find it. This is taken very recently, I think just a month or two ago. Can you see the Milky Way here? Here's the trapezoid, here's the handle, here's the spout, and here's the Milky Way, and this is the center of the galaxy. Okay, awesome. And some of this was also taken by our club member Lee Coombs. He has done a number of these. He did the Helix Nebula, which I believe we are talking about next month. This is going to be one that you can see with binoculars and telescopes. He took this out of an 8-inch telescope. Okay. And here's another image, also from Lee. This is the Veil Nebula. This was taken from an 8-inch telescope. We covered this in our Halloween astronomy from last week. Okay, and this was a Newtonian telescope. And this is the Cirrus Nebula that Lee also took.
Wonderful images.
Aren't they beautiful? This is M27, and this was taken in, I think this was an 8-inch telescope of his. And you can see it here. And I think we covered the Dumbbell Nebula maybe 3 or 4 sessions ago.
Right. Yeah, back to the summer object, so
summer
a little while
object.
ago.
You can see the beautiful colors in there. So you can learn more about that one from our previous one. And then another astronomer took this picture. This is courtesy of Scott Beer from our astronomy club. Do you recognize this one? What do you think, Brian?
Oh, I'm thinking that's Andromeda, M31.
Yes, that's M31, exactly. Scott also sent this picture over. And so here's another Milky Way picture. And you can see Jupiter and Saturn. And then we had Steve Williams. He had set up his his stargazing session, it looks like he's inside of a dome here. So this is part of a monitor, and I think they're just looking at the moon. And so this is somebody, wait, no, that's a Coronado. That's a solar telescope. Okay, I'm not sure what's going on here. You wouldn't be using a solar telescope on a moon. So he must be doing something. He might be doing a presentation and also doing some lunar observing. So thank you to Scott and Steve and Lee. And then Peter was just playing around with his brand new telescope. Here, he actually has a plane wave now, which is an incredible telescope.
Oh, very nice.
Yes. He has a 12.5. It is now up and operating. You can see it here. And he was imaging, this is the Bubble Nebula. And he was playing with filters. This is an O3 filter. Or no, this is an H2A filter. And so this is a image from Peter. Is this the elephant? I think it's the elephant picture. And so he sent a number of them. And this is the North American Nebula. This is NGC 7000. Aren't these great?
They are really nice pictures.
Yeah, so kudos to all of our members that have been helping us. I know, Dave, you gave us like hundreds of pictures. So I'm hoping Brian, as I'm talking, is going to pull up his favorites, because we would be here all night. But thank you, all of you who came to my rescue, and I wanted to share some images. And so over the years, CCAS has provided talks for getting started in astrophotography. So if you like to take the idea of taking pictures like this, it's like, how do you do it? Especially when you look at something like this and you think, oh my goodness, how complicated that looks. I couldn't possibly do it. Peter's only been doing this for, I think, 2 years, maybe a year and a half. And so, and it's one little piece at a time. You first start by doing sessions like this, where you get to know the star patterns, and then you use your set of binoculars, and then you graduate to a telescope and a star party, and then you start to get even more interested. So it's a passion for life. Speaking of which, is it okay to talk about equipment yet? Can we do that?
Let us do equipment. That's a very good idea.
Let's do equipment. You probably have a ton of, it looks like I'm in a telescope store. I actually didn't have all my telescopes out. I didn't bring my refractor, and I'm missing a few things here. Okay, so what do? You love stargazing. You love the idea of astronomy. How do we do this for real? Well, you go outside and you look up. It's that easy. The next thing you do is you get yourself a pair of binoculars. These are Celestron. They're $35. You do not have any excuse not to have a good pair of binoculars. So Celestron makes these. These are 7x50s. These are great for kids. 7x, so it's 7x 50. The 7x refers to the magnification. So I'm looking through here. I'll see things magnified 7 times their normal size. The 50 refers to millimeters. So this is 50 millimeters of the large diameter. So if you're looking for recommendations, grab a pencil, because I'm just going to tell them to you quick. So 7x50s are great, especially for beginners. If you want something a little bigger, you can get 10x50s. I wouldn't go any bigger than this, because you're going to be looking up, and the strain on your neck is like, oh, it's going to be, so it's a pain in the neck after 10, 15 minutes of this. Typically what people will do is they will put down like sleeping bags or like inflatable rafts, or just move the most comfortable chair in their house outside, and they'll just stargaze, and it'll be so comfortable. And it's especially great if it's something that can swivel or something that can recline, especially if you put a little heated blanket on there and like a cup of hot cocoa. You're going to be out there all night. It's going to be so much fun. So again, these are Celestrons. They're called Cometrons, Cometron, Celestron Cometron. And so these are a great pair. Orion makes a great pair. Really, if you have a pair of binoculars, use them. You don't have to buy new ones, but if you don't have them, this is a good referral. You want to make sure if you're buying used ones, shake them. If they're rattling, put them down. They've been dropped. So you don't want to be stargazing with those. So really, any pair of binoculars is going to be great just for getting started. And do you want to add anything on the binocular end there, Brian?
No, I just think that I would like to say that binoculars are awesome to start with, and really help you to start to learn the night sky and learn those constellations, and even just to go out and start exploring is a great way. You can explore and then write down what you're seeing and then go figure out what it is you just found. It's a great way
Yes.
to learn more.
And that's exactly how Kent started. You know, if you when I ask him once in a great while, I'll say, "Tell me again the story of how you started." And he'll say he got his H.A. Ray book and he just learned a new star pattern every night. And he went out there and he learned a different one and then another one and another one. And now he's like the world's expert. So
Yes.
so that's how you start. You just do little bits at a time. There are great reference books. I see Brian is going to show you a book here in a second. There are a number of great ones out there. You just got to find the one that you really like. Terrence Dickinson is great. Oh, did you get his Night Watch? I was just going to say Night Watch from Terrence Dickinson. Perfect. This is a great, it's a practical guide for viewing the universe. He took all the pictures. I think he took all the pictures himself in there. And he also has a spiral bound version, so it stays open.
Yeah, it lays flat, right?
Yes, there it is. That's the one. Very nice.
There's open up to the Orion Nebula.
Perfect.
You know what I really liked about Night Watch is he takes you from the beginning. He provides first a perspective of our universe from starting at our planet and zooming out, and then takes you through the basics of binoculars, basics of looking for a telescope, what to do and what not to do, and then in the objects available different times of the year. So it's a really well-rounded book.
Yes, and he does do it by season, which is great because it's going to vary what you're going to see. As you've noticed, we have a different thing we talk about each time. Okay, I got some questions that came in asking what's in my eyepiece case, and I just happen to have it here. Okay, so this is one of the eyepiece cases. So after a while, after you get into this, it's really fun to go to star parties and say, "Ooh, what's in yours?" Right? And so this is how you try out new eyepieces. Okay, but first, before you do that, you need a telescope. Okay, and so before I do that, I should probably mention, I usually get questions about these. My husband calls these my Looney Tune binoculars because they look like something from a cartoon. Now with the telescopes here, they don't quite look as huge as they normally do, but I'll hold up like a little pair of binoculars and then I'll hold up these. And you can see, I mean, this is the size of my head. So these are enormous. These are 100 millimeters, and so this is a 25 by 100. So it's magnifying 25 times, and it sees about the same thing as you'd see in a 4 or 5 inch telescope. And they're amazing, and it's binocular vision. This is really great, especially binoculars are great for kids who need both eyes. They have a hard time just closing one eye and focusing on that other eye. So it can be a little frustrating, especially if you get kids telescopes a little too early, especially before they know where to point it. So this one is made by Uberwork, and it comes, you have to buy it with a tripod because they're so heavy. I think they're like 12 pounds.
Yeah, you have to have a tripod.
Have to have a tripod. Okay, I have 2 other telescopes here. This is an 8-inch. Again, 8 inches refers to the diameter of the main mirror that's way back there. And so the light's going to come back to the mirror, and then it comes back up. And then there's a little mirror here that's on a diagonal. I don't know if I can get it pointed towards you. There you go. And
yep, we can see it.
You can. And then, so the incoming light from stars is going to be coming back to that mirror, comes back up here, and then it's going to hit that mirror at a 45 and then go, or at a 45, and then it's going to go ping out the eyepiece. And so what I attach here is different depending on what telescope I'm going to be using. So, for example, if I have an 8-inch reflector, it's going to be different. Different eyepieces will perform differently versus if I had a 20-inch, because and not all 8 inches are the same. So, before you go out and buy a whole bunch of eyepieces, typically what we would recommend is we would recommend going to a star party, trying other people's eyepieces, and seeing which ones really work best for your telescope. I remember how bummed I was when I got a really, really fancy eyepiece and I couldn't back it up enough and it never came into focus. And it was so frustrating. And at first I thought that, anyway, I thought all kinds of problems happened. The type of telescope you get is going to depend on what you want to look at. So if you really are excited about looking at the moon in detail and you want to see any of these would do the moon, but the moon in detail and the planets, and you don't want a really big telescope, a refractor is usually a great choice. Most people for their first telescopes typically will get a reflector because they're good all around telescopes. This will do planets, this will do the moon, this will do with a solar filter, it'll do the sun even, which is a whole nother ball of wax. This will do deep sky objects. So it's usually a good workhorse just for getting used to seeing things. And when you want to go into more detail, then I decide, ooh, I really am all about deep sky objects, or I'm only about planetary nebula. Then you can pick your telescope based on what you want to see, as well as where you are in the world. That's also going to depend. You're going to have different filters. You're going to have different eyepieces, depending on your viewing, where you are viewing. All right. So this guy is about, I want to say, today he's probably $700 or $800. If you have GoTo installed on it, it's going to be more. This is an Orion Newtonian 8-inch reflector. I think it's a Skyview Pro. And so if you want more details about that, I can share that with you. This one over here, this is a Meade LX200, and you can actually see it pretty well. He's really short. Look at how short he is. And let's see if I can turn him this way. Okay, notice how he's like really little, but it's also an 8-inch. And so I like showing these two together because they're the same diameter. This one is 3 or 4 times as expensive as this one. So this one has GoTo installed on it. It's got a lot more glass, got a lot more optics, so it's going to be more expensive. Typically people will buy these because they either are short on space or they want to do a certain kind of photography. The eyepiece on this one is here up at the top, which is a problem. Here, let me show you. Sometimes if you want to look at an object that's way up high, I don't know if you can see this, now the eyepiece is clear up there. So that can be a problem. And here we go. Let's see if I can lock him back in. Okay, so let's see. All right, Brian, you want to go ahead and talk for a second? Let me get him.
Sure.
I know I didn't put all the counterweights on, so I thought I could get away with it.
So this is a good opportunity to bring up something. When you first learn to set up your telescope or even to work with your binoculars, do it in daylight. Don't look at the sun because you need very special filters, but work with your equipment, set it up while it's fully light outside. Don't try to wrestle with it the first time you ever use it. In fact, there are certain telescopes that are called hobby killers because they can be complicated and difficult to set up the first time if you're not aware of what you're doing and if there's some false advertising. You won't get that from places like Orion telescopes. But it used to be, for instance, if you went to, let's say, Sears or JCPenney, you'd look at these amazing pictures of Jupiter or the Orion Nebula on the box that you could never accomplish with that telescope. But again, set up the telescope during the day, learn how to use it, learn the parts, how to adjust it, so that when you do at dark, you'll already be used to how to move the scope around.
Awesome. Yes, that's really, really true. And if you see something that says 1200X on the box, put the box down and walk away. Run away.
Or run, yeah.
Telescopes are not about the magnification. They're about light collecting ability. They're light buckets. So the bigger the telescope, the more sharp, the more you're going to see. And so typically if you're looking at getting a telescope, we usually recommend a 6 or an 8-inch. If you've got kids, we recommend the ones that have the mount on the near the ground, which are Dobsonians. I know Dave Majors has used those. A number of us have started with these reflectors. Everybody wants a rickety refractor up on stilts, you know, because that's what they think a telescope should look like. And so the best bang for the buck is really to get a Dobsonian. You can get one that is an 8-inch like this for only a couple $100. And you'll get started, which is great. And then after that, then you can start saving for other things. If you are in the market for a telescope, here are a couple of things from my eyepiece case. I actually enjoyed the Easy Finder. It's a laser that it projects. It has a piece of glass in here and it projects a dot. And when I look through it, it puts a dot on the sky. And so it makes it easier to find things. When I look through the telescope, I'm going to be zoomed in. And so telescopes will have, this one has it right. Let's see if I can show it to you. This one has it right up here. Ooh, I don't know if you can see it. Let's see if I can undo it. There's a tiny little telescope up here. And so that's going to help me kind of zoom in before I zoom in even more. And so an Easy Finder replaces this finder scope. And so it makes it easier for me to find it. Now, one of the things that people are really surprised about, Brian, were you surprised the first time you look through a telescope and you're like, wait a minute, it's upside down and backwards?
Yes, exactly. You start to move it and I'm going the wrong direction. Yes.
So because of the optics of the telescope, the finder scope, you may say in the finder scope, oh, I need to go a little to the right, and you go to the right, and then you look at the telescope and you're like, wait, I went to the left. So it can be hard initially to get this right left, and so the finder scope actually keeps that from happening. But yeah, telescopes are, they have optics in there, and so it's a surprise sometimes. I use a headlamp so because I can't find things. It has a white mode that I rarely use, and as well as a red mode. That's also in there. I have a green laser pointer that I use just for pointing things out to the public. Let's see what else. I have a bubble level that will help me. I just stick it on the tripod itself to make sure the tripod's level before I... this mount over here, I will actually look through the mount and find Polaris. And that way, I only have to move one knob all night long if I want to track that. If I'm looking at the star, and people are surprised when they look at it, and then they'll notice the star will move through the eyepiece. And they're like, wait, where did it go? So like when you look at Jupiter, it was there a minute ago, and you walk away and you come back and you're like, where did it go? Because everything is moving, right? Everything is rotating. So if you set up the telescope to aim straight at something that's not moving, you'll only have to move one of the axes in order to maintain that. If that made no sense, don't worry about it. My favorite eyepieces you can't find anymore. Okay, so Brian, I don't think I've ever shared this before. My favorite eyepieces on the reflector telescope are these really hard to find. See if I have them here. You can see this one better. The other one's coming off. It's an Orion super wide 65-degree lanthanum multi-coated, and I actually use a 17 millimeter the most. Everybody's different. They had these many years ago, and I bought a bunch of them. I bought a 22. And people constantly would ask me, what's the magnification? So I went through and I calculated it and I stuck it on the sticker on the side so I could just quickly look and say, hey, we're at magnification 45. So I didn't have to calculate it each time in my head. And so I have just a few. I don't have that many. I have a 13. And it just depends on what I'm looking at. And this is one I never use. I have an 8 in that series. And you'll notice it's huge to look through here. It's not like the little ones that you normally get when you buy. Do you have one on you? I don't think I do. Let's see. Do you have a regular eyepiece like a Plossl or something, Brian?
I actually have believe it or not, a 32 Urfel that I use a lot.
What?
And
Let
that's
me see.
because I use that on my 20-inch telescope. So
I didn't know you had a 20-inch telescope.
Yes.
Whoa, I'm coming to your house. Okay. This is something else that I use. It looks a little funny. It's a variable polarizer. So I screw these two pieces together. It's like two sunglasses that fit one on top of each other. And it only does one job, but it does it really well. And you screw them together, and then you screw them to the bottom of one of the eyepieces. Or, if you're smart, you have one of those sleeves. I forget what you call them. It's just like an extension barrel, and then you can turn the eyepiece as you're here to adjust it. And so what it does is each one of these is a polarizing lens, and so that means that I can vary the amount of light that travels through. You can see how you can see through it, and then as I rotate it, it goes dark. And then as I rotate it some more.
That'd be very handy for the moon.
The moon, right? Because the first time everybody thinks, oh, let's look at the moon tonight. It's full. And then they put the telescope on the moon and then they look through it and you're like, ow! Because it's really, really bright.
Talk about seeing spots.
Yeah.
In fact, I mean, I've been reading that it can actually, if it's full, it can actually injure your eyes if you look at it. So
it can.
Filters are good.
Filters are very good, and somebody gave me a Sky Glow. I don't think I've used that. The one I use the most is my Lumicon Oxygen, my O3 filter. And so this is, is Lumicon still making filters? I don't even
I'm not sure.
I don't know.
Actually.
I don't think they are.
I know Bader Planetarium has a really good series of
Okay.
filters also.
So that's good for seeing things like the Orion Nebula or something like that, where you just need to look at certain particular wavelengths. And so Kent is a big, he loves his oxygen 3 filter. And so you'll hear him say something like, if you blink the O3 filter, and what he means is you're looking through here. If I'm looking at the eyepiece, he means grab that, if this was the filter, grab it and kind of blink it through so you can see the before and after. And so you can really have something to compare. And you'll actually see things that weren't there before, which is just amazing. I think that's all I probably want to talk about now. We can save some of this stuff for later. Is this useful? Are you guys finding this interesting?
Yeah, lots of great feedback from the chat.
Okay.
And in fact, we had a good question. Jeremy had asked about any tips for observing when you wear glasses.
Ooh, that's a really good question. You and I
yeah,
both wear glasses. Do you want to take
yes,
that one first?
Right. And the first trick is, the question is, are you observing on your own or during a public star party? If I'm just observing, then I'll take my glasses off and focus to my eyesight. Mm-hmm. And I crank and crank and crank until it's in focus with my glasses not on. And it's much more comfortable to view that way, I find. But then, of course, if you want to share with someone else, then you need to refocus it. So if it's with a group, then I'll focus to the best of my glasses, but then often point out to people, hey, if, look for a star as a point, and I show them the focus to at least make an adjustment.
Yes, and you can get started with that by easy stuff like the moon or Jupiter or something big. To help with that. And you want to practice during the day. So get your telescope out. Again, please don't look at the sun. Don't even think about it.
No.
But if you look like the leaves on a tree from a distant hill or something, and just get used to what it's going to feel like, and see if you can do it without looking at the knobs, because when it's dark, and especially depending on the kind of mount you have, those knobs are going to move throughout the night. So you need to know where that is and where the focuser is.
I want to...
Yeah, go ahead.
Something really, and now for a public service announcement. When you go and use someone else's telescope, do not reach towards it if you may have any possibility of touching the eyepiece lens. Finger grease and eyepiece optics and coatings and fingers are not compatible. Worst thing you want is a fingerprint on your lens. So don't reach for a telescope unless you have permission, please. And then even when you're using your own, be careful to keep your fingers away from the optics.
Yes.
It'll keep everyone much happier. And
yes.
While I have the floor, if I could really
Please.
quick point out, I don't have any, I have a camera with me, so I'll just use this as an example.
Okay.
Something else to think about when you go to a public star party is a good way to look for this. There's a measurement called eye relief, which is how far does your eye need to be from the eyepiece in order to have the focal point. And when you use glasses, then I encourage you to check for eye reliefs that are a farther distance. That way you won't have to get right up on top of the eyepiece in order to have everything a proper view and see the full field of view for that eyepiece.
Yes, and it actually will say mine's been scratched off, but it actually says long eye relief, and so that's one of the reasons we like this.
Awesome.
For star parties. Kids typically will not want to put their eyeball next to there, and so it's hard for them to actually bring their head forward. If you have astigmatism, you want to leave your glasses on. The telescope can correct for just about everything except for that. If you just have a mild astigmatism, then it's okay. But just play with it and practice. It's best to take the glasses off and tune it to your eyes. One thing about binoculars, these are individually focused. So on the back end, each of these I focus to each eye, because each eye focus is different. If you have a pair of binoculars like this, you'll have a center focus and one of them will rotate. And so you do one and then you do the other.
And when we talk, Aurora, about changing out eyepieces, that's really for telescopes, right? Not binoculars. Oh. Binoculars usually have fixed eyepieces.
Oh, yes. Unless you have one of those rare binocular telescopes.
Oh, yes.
Yes. Those are super expensive and people usually don't share those.
Yes.
And then you need 2 eyepieces of each kind. Yes, so for eyepieces, it's just for telescopes. Binoculars have their eyepieces attached. And actually, I just called the manufacturer, the guy who physically made this set, because I had a question. I said, can I put any filters on here? Is there a way to like remove these and put something on the inside? I wasn't sure. And he said, oh, let me think, which one do you have? Because actually we changed that, because by doing that, it used to be on really expensive binoculars, you could take these off. But it changed that eye relief we were talking about so much, and it made it that your eyeball had to be just about touching. So they don't do that on binoculars anyway. So that's just something to keep in mind. So these eyepieces that I'm showing you are just for telescopes. I have a really funny looking telescope I can show you. It's on the floor. It only does one thing, but it does it really well.
Yes, hydrogen alpha solar telescope.
So this one only looks at the sun, can't look at anything else. And so this is a solar telescope. They're about, I think, $500 or $600, and it only looks at the sun, but it does it in such an incredible way. When you buy one, you're going to be everybody's best friend, just because the images are so gorgeous. I'm going to grab an image really quick. Do you want to mention anything else?
Oh, I think we're good. While you're bringing up an image, we'll point out not only is that a solar telescope, which is blocking most of the sunlight so that it's safe to look, but it's giving you a very narrow wavelength. That solar telescope, as David typed in, is called an H alpha. And what that means is it's giving us very specific wavelength of light. And as you adjust it, this allows you to see details either on the surface of the sun or potentially prominences or flares coming off the edge. So really nice to have those when we do public daytime solar observing, for sure.
Yes. And just to be super, super clear, we are not using these, we do not use our telescopes to look at the sun. And in fact, when we do, you have to have super special ways of doing it so you don't damage your eyes. So if you've ever seen those experiments like where people are taking a magnifying lens and they have like a piece of paper under it and they put it in the sunlight and it concentrates it on the sunlight and brings it down to a point, and then it reaches the flash point of the paper and the paper starts to ignite. That's what's happening to your eye. What's happening to the paper when you look at the sun through anything with lenses. And so whether they're binoculars, telescopes, doesn't matter. So that's why we always teach kids, we teach anybody we can talk to, never, ever, ever look through anything with lenses at the sun, because was happening with the paper and the magnifier will happen to your eyes, and there's no way to reverse that damage then once it gets done. So astronomers that are interested in solar observing, what they do is they reach out to other astronomers who have solar telescopes and learn the proper ways to do it. Okay, exactly. Just wanted to put that little plug out there. Okay, do you have any other last questions before we wrap things up? We have been going for 2 hours.
Yes, believe it or not, boy, we could just talk forever about astronomy.
Yes, oh, we could, and people would go to sleep. Okay, but it's time for you guys to go outside and look for your things. Yes. So what have we covered tonight? We have covered Jupiter and Saturn. We've covered Sagittarius. And what else have we covered? We covered 2 more planets. Mars, and what else? Venus. And Venus is a morning object. So you'll be able to see 3 of those that I just mentioned, Saturn and Jupiter and Mars, right now. So if you go outside in the northern hemisphere, you're going to find Mars by looking east, and you're going to be finding the other ones like we showed just right above Sagittarius, kind of southwest. And then what else did we look at, Brian? Your turn.
Well, I'm actually just answering a few questions. So in addition to the planets, we also looked at Andromeda Galaxy, which is M31, and then the Pleiades Open Cluster, which is M45. Okay. So those were our 2 deep space objects. And in addition to those objects, we talked about the constellations Perseus, Andromeda, and Pegasus.
Yes, and we covered those particular constellations last month in detail with Kent. So if you'd like to go back and look at the September one, just because it says September and now we're in October, don't think, oh, I couldn't possibly listen to it. Those objects are still up. So we have even more objects to add every single month. So you can definitely look at those. And depending on how late you stay up, more objects are going to be up. And so once you get a feel for the different objects as we go through, it's going to be better and better. So if you just learn one new constellation, one new star pattern each week, by the end of the year, you're going to have a lot of them covered. Okay, so any other last minute things? We have a website. We do have
Yes,
a
we
website.
do.
So
I'll type it in. It's on the bottom of the screen still.
okay, so our website is, this is Aurora and Brian from the Central Coast Astronomical Society. You can find us at centralcoastastronomy.org, and I did promise to show you where the handout was. Let me do that right now. So here is centralcoastastronomy.org. And by simply going to the website, here is the special Halloween astronomy broadcast. This is the one I did with Kent last week. And simply by clicking where it says print the handout here, you'll get that handout I mentioned and click the video to get started. And if you go under Stargazing, you can take a look. There are different events. This is the one we're doing right now. So this is how you connected. And these are the stargazing events that we've had before. And so you can look into those. If you're a member, then you can join us for our virtual member hangouts. We do these once a month. And so it's easy to become a member. All you do is go under membership, not a member yet. And it's $20 for the entire year. So it's such a deal. And then you can be a part of this. You can just hang out with our members, ask them lots of questions. And we've actually had some kids participate recently, which has been awesome to see the younger generation getting excited about astronomy.
And that so, younger generation's bringing some amazing questions with them too.
Yes. So there have been a few who are like, uh-oh, hang on. So if you do have any questions, feel free to join us, email me at questions@centralcoastastronomy.org. And so Brian, I want to say thank you. He's the one who actually organized what we were going to talk about tonight. So yay! So thank you, Brian, and thank you all for joining us. I am so excited that you are into astronomy. It's just been so fun to see this interest in this hobby just exploding. So thank you again. If you do have questions, let us know. You can just simply write to questions@centralcoastastronomy.org. And I hope you guys have a great night. Thank you, Brian. Thank you, everyone. And
all right, thanks, Aurora. Thanks, everyone, for joining. See you next time.
You got it. Thanks. Bye-bye.